like maybe iron oxide. Then you mix it in with potassium, because potassium is more, so if you have like yes, because it is more reactive, it
Mhm.
will, yeah, it will displace the iron, so
Oh,
it
good.
becomes,
Mhm.
yeah, it becomes potassium oxide. Then it displaces iron, so you
Okay.
get iron as your the metal that you wanted, and
Uh,
that helps you extract metals.
Oh, good. So you have talked about the displacement reaction,
Yes,
displacement.
yes,
And you have talked about something which is very important, that during the displacement reaction, the more reactive metal displaces the least reactive metal from its compound. And I believe we looked at that also in reactivity series when we are still in senior 2. So that is very good. And we see that even those displacement reactions are redox reactions because they involve change of oxidation states. That's why today we're going to look at oxidation states so that we can understand what an oxidation state is and how it can help to identify a redox and non-redox reactions. Thank you very much. Maybe let me have another person to explain for us the next 2 points. Thank you. You didn't tell us your name.
yes.
You have ITEL, but you can tell us your name.
My name is Maria Martha.
Okay, so that is Martha. Okay.
Yes,
Let's have another
thank you.
person. Nora. Okay, welcome. Nora, you can take us through the second point. Nora, yes.
Production of chemicals.
Okay.
Many important chemicals like sulfuric acid, nitric acid, and hydrogen are made using redox reactions.
Okay. Explain for us something small there.
I don't have anything.
Okay. But we are looking at production of chemicals, and they are telling us that in many important chemicals like sulfuric acid, do you know the process or the reaction which brings about sulfuric acid? Do you recall them? Some of them. I believe sulfuric acid undergoes a number of stages, yeah? And the very first one is the reaction of sulfur in what? Sulfur in what? Oh, you have gone off. Okay, Babu, let's move together with Babu. Babu, you unmute. Okay. So we are trying to talk about Babu. Are you there now?
Yes, teacher.
Okay. Now we are looking at production of chemicals. Can you tell us something small? Do you think you can explain for us something small on that?
Me, what I know, sulfur
Mm.
is an acid.
Yes.
Me, what I know that sulfuric acid is got from an acid which is mixed with hydrogen and a salt.
Okay. Have you looked at manufacture of sulfuric acid?
We have not yet.
Okay, but you have looked at it also. You check very well in the chemical reaction rates. That's when you're ending, that's why I look at sulfuric acid. But also in our next lesson, maybe I'll also come along with it because that is senior 3 work where we look at the manufacture of sulfuric acid. And the very first step in manufacture of sulfuric acid is sulfur reacting with oxygen to produce sulfur dioxide gas. Now, when you look at this one is under oxidation reaction also. So what are we saying? That the whole of all these chemical reactions that are taking place, they are redox, but in those reactions which are taking place, they are helping us in production of useful chemicals like sulfuric acid, like nitric acid, like hydrogen gas. And all this It's due to the redox reaction. Are we there? And we said that redox reaction involves both oxidation and reduction processes. I believe that one is clear. Babu, read for us the third point as we.
Electrochemical processes used in electroplanting, electrolysis, and batteries to produce metals, chemicals, or electricity.
Okay, thank you. You can remain on the call. We're going to move together. So that the third point, you're saying that another application of redox reaction is under electrochemical processes. So these redox reactions, they are used in electroplating. I believe this is one point where we looked at when we were reducing on rusting to prevention of rusting. This is one of the things which we all normally do, electroplating. Then electrolysis, as I said last time, this will be our next session, which will be marking the end of this topic that we are on. That will be our next Monday when we are getting done with this topic. We shall be looking at electrolysis and then the batteries. And they're saying that when they are used in such, they help to produce metals, help produce chemicals, or even in the production of electricity. So all those are areas where these redox reactions or take up applied. Then number 4, maybe can I have the last person, Abigail? Abigail, Abigail, are you there? Abigail, are you there? Oh, okay. Joel, Chris, take us through the last point, the second last. Joel, Chris. Okay. Yes, Joel, Chris.
Yes, Chair.
Yes, please.
Energy production.
Mm.
Fuels release energy through redox reactions, and fuel cells use them to generate electricity.
Do you recall our first lesson? We looked at different processes where we had also the burning of some fuels, and we're able to see that even when we are burning fuels, one species, for example, we are having which fuel can we talk about? Maybe let's talk about methane. We are having methane, which is burning in what? Oxygen. What do we produce? Joel, I'm with you. Methane, when it reacts with oxygen, what happens? What is the product?
I'm not very certain.
Yes?
I'm not very certain of it.
Who is certain about the products? When the hydrocarbons react with oxygen. Joel, you can remain there. Let me see. Doreen, do you have the answer? Yes, Doreen. Doreen. Okay. Doreen, what is your answer? Mm.
No, I wanted just to try to explain something about
Yes.
energy production.
Yes, please.
Okay. For me, what I can explain about that is because energy production,
Mm.
they involve the transfer of hydrogen electrons, releasing significant energy as electrons move from low electronegative atoms to move more electronegative ones like oxygen.
Mm.
Yeah, that's what I know about that point.
Okay, thank you. Yeah, actually, what you're trying to explain, it happens right here. When you get our product, when we have a hydrocarbon which is which is reacting in air, we get carbon dioxide gas and water. Carbon dioxide gas and water. But of course, this is not a balanced equation. We can be able to balance. Let me hope we learn how to balance equations. So this side we have one carbon atom. Here we have one. That is okay. This side we have 4 hydrogen atoms. This side we have 2. What do we do to hydrogen? Someone on, please. We add a what?
Teacher, we added 2 in front
We
of
added
A.
here.
Yes.
So hydrogen atoms, they become 4. Even their side, they are 4. Then oxygen atom, they have become how many? How many do we have this side? We have 2 here, and also 2 times 1, they become 2, which means we have 4 oxygen atoms. Are you seeing it, Joel?
Yes.
But on the other side, we have only 2. So what do we do to balance? Joel, are you there?
Yes.
This side, there are 4. Here we have only 2. Which means if we want to balance, we can also add a what? A 2
A2.
here, and then they become 4 oxygen atoms. Now, here they are saying that fuels release energy. So when methane reacts in air, it produces carbon dioxide and water plus energy. It releases also energy. Energy is released. And we are saying that this reaction which is taking place is a redox reaction. Why? It involves both oxidation and reduction processes or reactions taking together in one reaction. We shall, as we said, we shall be able to see which one is undergoing oxidation between methane and oxygen, which one is undergoing reduction between methane and oxygen. But we are going to look at that in today's session as we look at oxidation numbers, that we can look at them very fast using that knowledge. Just in a few minutes, we shall be able to look at that. Okay, Joel, thank you very much. Let me have Melvin take us through the last point. Melvin?
Waste treatment and pollution control.
Okay.
Redox reactions help remove or neutralize harmful substances in industrial waste.
Do you have something to tell us?
Okay, sir. By this, I think they mean, remember some of the pollutants are acidic. So these redox reactions help to neutralize or to make them like, less harmful.
Less harmful. Good. Yeah, like as you said, some pollutants, they can be maybe acidic, and then we need to add in an alkali to neutralize it, form a salt and water, which is neutral. Yeah. So when that reaction takes place, we are saying that that kind of reaction that is taking place, most of them are called redox reactions. Why? They are involving oxidation and reduction taking place at the same time. Are we there?
Yes.
Okay, thank you. We can now mute. Okay. Let's go to today's work about oxidation numbers. So today we want to look at oxidation numbers, or what you're calling oxidation state, and we understand what is an oxidation number. What is oxidation state? I want by show of hands, who can tell us through that very fast? Josephine, are you ready? You unmute. Josephine, what is oxidation number?
Teacher,
Yes.
good afternoon.
Good afternoon.
Teacher, I was mainly asking a question.
Yes, please.
I was requesting if you could help explain on the topic of displacement. I didn't understand it quite well.
Oh, displacement.
Yes.
Okay. We are going to move a little bit fast. At the end of it one, we can have a simple example of a displacement reaction.
Okay.
Okay, maybe just not to, because I know time may get us, but you remain on the call and I give you an example here. If we have,
Okay.
do you recall reactivity series?
Yes.
The arrangement of metals in the order of their reactivity. Are we there?
Yes.
Now, when we talk about displacement reaction, is that reaction in which the metal which is more reactive displaces another metal in the compound, but which is less reactive than that metal. For example, if we have iron metal reacting with copper to sulfate, aqueous, which product do we get? Josephine? Josephine?
Yes.
So in which
Yes.
product, do you know the products we can get here?
Not really.
Now, when we know the displacement reaction, it will become very easy for us to guess even the product. Not only guessing it,
Okay.
but we'll be knowing the product. Why? Now, we see here two metals. The first metal we see, which name is given to this? This is which metal?
Iron. Iron.
Then in this compound here, copper sulfate, which metal are you seeing there?
Copper.
Copper. Now, between copper and iron, which one is more reactive?
Iron.
Now, because iron is more reactive, it is going to displace copper from this compound and then it forms iron sulfate. So which means our product becomes iron sulfate, iron 2 sulfate, which is be aqueous plus. Now, copper has been displaced from this compound, so it forms copper solid. So here we say this is a displacement reaction because the least reactive metal copper has been displaced from its compound by a more reactive metal, which is iron. Are we there?
Okay, teacher.
Yeah, that's why the
Yes.
other lady, the first one, Alia said that in this redox reaction, because even this is a redox reaction, and she said that this redox reaction can help in extraction of metals. For example, here, you are able to extract out copper from the compound. So this is extraction of copper, and this is a redox reaction where it is being applied in this extraction of copper. Okay,
Okay, teacher.
thank you. Welcome.
Thank you.
Okay, well, you're welcome. So anyone to respond to this question? What is oxidation number? Hunjin, Jihan, Hunjin, Hunjin. Okay, Hunjin is not unmuting. I want us to be unmuting very fast so that we can move a little bit faster. Let me have another person. Mancharis. Mancharis. Yes, Charis. Please, if you don't have the response, let's always put down the hands so that we can move with those who are putting up the hands, they are able to respond. Maybe Alia, and you mute.
Okay, sir.
Mm.
Oxidation number,
Mm.
the total number of electrons that
Total
an
number of.
atom electrons
Mm.
that an atom gains or loses in order to form
Gain.
a chemical that an atom gains or loses in order to form a chemical bond with another atom.
To form a chemical bond.
Yes,
Bond
with
with
another
another
atom.
atom. Okay. Okay, thank you. That is Alia who is saying that oxidation, the total number of electrons that an atom gains or loses. What about valence. Alia,
Yes.
what about valence? How do you define valence?
Valence. I think valence is the number of, is it electrons
Mm-hmm.
needed? Is the number of electrons lost or gained by an atom to become stable.
Become stable. Or
Yes.
the combination power of an element. Okay, thank you. We shall be able to confirm your point. Okay, let me have another person. Thank you very much. Gemma, unmute.
Yes. Good afternoon, sir.
Good afternoon.
I think oxidation number is the
Mm.
hypothetical charge of an atom if all of its
Mm-hmm.
bonds to other atoms are fully ionic.
You say it is a what? Which term did you use?
I use hypothetical charge.
Hypothetical charge. Uh-huh.
Of an atom.
Of an atom.
If all its bonds.
If all its bonds.
To other atoms are fully ionic.
To other atoms. Other atoms are fully ionic. Please, other people, okay, thank you. Other people who have responses, let's put in the chat so that I can be able to see your responses also. Okay, thank you. That is, what is your name? Okay, she has gone. It's all right. So we have two people who have given us their responses. The hypothetical charge of an atom if all its bonds to other atoms are fully ionic. Then another one said, these are total number of electrons that an atom gains or loses in order to form a chemical bond. Now let's look at this. Let's look at this. Philip Mangeni, read for us that definition that we have put there. Philip Mangeni. Victoria, Rihanna. Victoria, read for us. Victoria. Oh, okay. Okay, can I have Eileen? Yes, Eileen. So there are those who are raising up the hand and they don't speak. So let's make sure that we put down the hands if we are not to speak. So let's put down the hands. Who is that? Yes, Eileen. Read for us.
Good afternoon.
Good afternoon.
The oxidation number or state of an
oxidation number or oxidation state.
I can see that you covered it, yeah. Oxidation number, yeah, oxidation number or oxidation state of an element in the chemical compound is a charge. Charge it would have if electron were complete, transferred, rather than shared.
So we are saying that the charge, you remain on the cone. We are saying that is the charge it would have if electrons were completely transferred rather than shared. So that charge that it attains, that is the oxidation state. So the oxidation state of an element in any chemical compound is that charge it would have if electrons were completely transferred rather than shared. And today we are going to expound more on oxidation numbers. By the time we finish this lesson, each one of us should be very versed with oxidation numbers and be able to apply it in any chemical reaction. And there's that statement which you have written down. Can you read for us, Aileen?
It helps in determining how electrons are gained or lost in redox reaction.
What is helping us?
Yes?
What helps? What are they referring to when they say it?
It helps in determining
Which
how
one? What are they referring to? It?
I don't know.
No, they are referring to this. You recall you have been defining oxidation what? Number or the oxidation state. So if you know the oxidation state of an element, it helps us in determining how electrons are gained or lost in a redox reaction. Are we getting that? And you recall, if you get to know that electrons have been gained, which kind of reaction is that? If they have been lost, which kind of reaction is that? If they are gained, we say that is what?
If the again that is the let me see, oxygen.
We are looking at electrons. If electrons are gained, we refer to that reaction as a reaction in which electrons are gained is known as what? Is it oxidation or reduction?
Reduction.
It is
Reduction.
And when electrons are lost, it is what?
Oxidation.
Oxidation. And then finally, we say that if a reaction consists of oxidation and reduction reaction, then we call that reaction a redox reaction. Are you seeing that? So, which means at
Yes.
the end of it all, when we understand oxidation number of different elements, it is going to help us to identify reduction reaction in a given reaction and the oxidation reaction. At the end of it all, we can be able to differentiate between a redox reaction and a non-redox reaction. Now, you can read for us these key points. There are these key points about oxidation numbers. Take us through those key points. Let me hope these ones, let's summarize them down because we're going to apply some of these things in our calculations. So let's make sure that you are very attentive and noting down something so that we can be able to respond as fast as possible. Take us through very fast. Okay. Are you still there? Let's have another person. Gemma. Gemma.
Yes, sir.
Gemma, please. Okay, take us through those points.
Okay.
Those key points about
Key points.
oxidation numbers.
Okay, sir. Key points about oxidation number. One, it represents the degree of oxidation, in brackets, loss of electrons of an atom in a compound.
First pause there. That if we get to know oxidation number, it helps us to know the degree of oxidation. That is the loss of electrons of an atom in a compound. So when you find that oxidation number of an element is 4, while another one is 2, which means the one with 4 has lost many electrons compared to the one of 2. So which means that oxidation number will be equivalent to the number of those electrons that have been lost, especially when looking at those atoms that are losing electrons in a given compound, or those ones which are gaining. So it will be able to, it will help us to understand all that. So we are saying that it represents the degree of oxidation, that is the loss of electrons of an atom in a compound. Okay,
Yes.
go to the next point.
It can be positive, negative, or zero.
Are we mastering those key points? That an oxidation number of an element, it can be positive, it can be negative, and also it can be a zero. We are going to look at the rules of identifying oxidation numbers. We shall be able to see all that. When does it become zero? When does it become a negative? When does it become a positive? Okay, continue.
The last one, it helps in balancing redox reactions and identifying oxidizing and reducing agents.
It helps in balancing redox reactions and identifying oxidizing and reducing agent. And surely today we are going to see how we can use oxidation numbers to balance redox reactions and also identify the oxidizing and reducing agent. That is what we want to see, how we can apply that. Thank you, Gemma, for that, for taking us through. You can mute, and then we have Galax. Galax A2. Galax A2. Now Galax A2, the hand is up, but is not. Okay. Abdul Shakul, you unmute. Abdul Shakul. Abdul, yes. Now, Abdul, I want you to take us through the first two rules of assigning oxidation numbers. So these are rules, and I would like us to look at the way how we can summarize them in our notebooks, because we are going to apply them in our the next questions we're going to have. So make sure that we summarize them. They are around 8 rules, but you can summarize them in your own manner. We shall have this document later after this lesson, but also let us have these ones recorded somewhere to help us in our discussion. Yes, Abdul, are you there? Abdul, your microphone is on. You can speak. Abba, you unmute Abba. Abba? Abba, are you there?
Yeah.
Okay, you can take us through the first 2 points, the rules of assigning oxidation numbers. Yes, Abba?
Yeah. The first rule is free elements.
Mm-hmm.
The oxidation number of any free, 2 brackets, and combined element is 0.
And now, do
For
you understand
example,
when they say, first wait, do you understand when they say
yes,
a free element, when they say a free element? Do you understand that one? Is it clear to you
nah,
when they say free element?
no,
So
no,
those are things I want us to first understand before we move very
okay,
fast. Now look at
okay.
this equation. Look at this. Okay, tell me any reaction that comes in your mind. Which reaction can we talk about? Which reaction?
Sodium thiosulfate and hydrogen chloride.
Sodium thiosulfate,
Thiosulfate and hydrochloric acid.
hydrochloric acid. Now, okay, this is where we get what?
Yeah.
What do we get here?
You
What
get
are our products?
sulfuric acid.
When you get sodium thiosulfate and you add hydrochloric acid, we get sulfuric acid.
Yes.
This is the reaction which helps in the production of sulfur. Do you recall that in the chemical reaction rates?
Yeah. I had forgotten.
But okay, but also you'll find out that this one may not bring out what we are looking for. Let's look at let's first look at this, the one I had given us before, where you have methane. Methane. Are you able to see where I'm writing?
Yes.
Reacting with oxygen gas to produce carbon dioxide and water. Are we there?
Yes.
Then we have aluminium reacting with oxygen gas to produce, what do we get? Aluminium reacts with oxygen to form what?
Aluminium oxide.
Good. Aluminium oxide. Are we there? Now,
Yes.
I want us to consider these two equations. We have number 1 and we have number 2. So here we have methane and we have oxygen. Are we there? Here we
Yes.
have aluminium and here we have oxygen. Where you are, there is some noise, so make sure that you get away from the noise, or you can make sure that you're away from the noise. So when you say free elements, I want us to identify free elements in these two equations, number 1 and number 2. And they're saying that oxidation number of any free element or an combined element is 0. Are we there? So between, you look at the reactants for equation 1 and reactants for equation 2. Which elements do you see that they are free elements, they are uncombined, and which ones are combined?
The first one, the uncombined.
You identify. Tell me this one is not combined, while the other one is combined. Which one?
Aluminium oxide is combined.
Okay, so aluminium is an element, but is in a here it is in combined state, yeah, because it is aluminium oxide, which is aluminium combined with the oxygen. Okay, continue. Where you are, there is a lot of noise. Maybe you can move away from that place.
That's not me.
It's not you. Okay. Okay, I think that it is clear. Let me have people coming now. Raymond? Raymond? Yes, Raymond. Raymond, unmute. Now Raymond is not responding. Okay, Lucky. Lucky. Please, if you're not ready to speak, let's put down the hands. That will save time. Lucky, are you ready? Lucky, unmute. Okay. I can see. Okay. Jonia. 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 Jonia, unmute. Jonia. Okay. So I can see people are putting up the hands, but they are not. Then there is AANN. Unmute. Double ANN.
Yes,
okay.
Please, teacher.
Okay, maybe next time you can always put the names so that you can always identify people with names. Okay. Now we are on number 1. I want us to understand it very well so that it doesn't always confuse us. We are talking about free elements. Are we there?
Yes.
And we're saying that the oxidation number of any free or uncombined element is 0. Now I'm asking, in equation 1, this equation 1 is methane reacting with oxygen to produce carbon dioxide and water. And equation 2, which ones can you identify as free elements?
I think in equation 1 it's oxygen.
Oxygen. Okay.
Then equation 2 it's aluminium and oxygen.
Aluminium and oxygen. Very good. So what is the oxidation state of aluminium here?
0.
So oxidation state of aluminium becomes 0 because it is a free element. Even oxidation state of oxygen here becomes a 0 because it is a free element. Can you explain to other learners what they mean by a free element and why they mean by a combined element using one of the examples inside here in these equations?
Okay, how I understand it is that, let me use the second one. Aluminium is being reacted with oxygen. And okay, to begin with, there are elements.
Yes.
Okay, I don't know exactly how to explain it, but before the reaction, they have their normal electric configuration. After the reaction, they either gain, one of them will gain, one of them will lose electrons. That means their charge will be changed to either positive or negative.
Okay.
So what I understand is that a free element has its original electric configuration.
In simple terms, when we say a free, if it is a free element, it is not attached to any other element. It is that element and that element alone. Are we there?
Yes,
like, for example, in the first equation, you say that oxygen is a free element. Why didn't you say methane is a free element?
Because it's okay, it's a combination of carbon and hydrogen.
Very good. So in methane, there's a combination of carbon and hydrogen. They are combined in one compound, meaning those are two elements which are joined together. But when we come here on oxygen, it is one element, but two atoms of the same what? Element. So that one becomes a free element. So we're saying that for any element which is free and combined, we're saying that that one, its oxidation state is 0. Take us through number 2, rule number 2.
Simple ions. The oxidation number of a monoatomic ion is equal to its charge.
What does it mean when they say monoatomic?
I'm not very sure.
Do you recall when you're in primary when they say dicotyledonous seeds and monocotyledonous seeds? Do you recall that?
Yes, I know mono means 1.
Mono means 1, di means what?
2.
So here they are talking about for a monoatomic ion. And in simple terms, an ion which is having only one atom. You recall we have other ions, for example, nitrate. Nitrate is written like this. So this is not a mono because it's having a number of atoms. Are you seeing that? But if you come to nitrogen alone with a charge of 3, now this one has become a monoatomic ion because it is having only one atom and it is having a charge. But these ones which are having a charge but they are more than one atoms, then those ones are called polyatomic ions. So they're saying that for simple ions, or what you're calling the monoatomic ions, the oxidation number of such is equal to its charge. So they have given us an example that if we have sodium ion like this, its oxidation number is positive 1. If we have chlorine with a charge negative, then its oxidation number becomes -1. For iron with 3 plus, its oxidation number becomes +3. Then for these ones which are free elements, we say that their oxidation numbers become 0. Are you seeing that?
Yes,
And
teacher.
now that one explained to us the other key point that we had, which said that oxidation numbers can either be 0, they can be negative, or they can be positive. I believe you see where the positives and negatives are coming from the
Yes.
charges of the different ions. So far we already know that if we have any free element, its oxidation number is 0. If you have simple ions, their oxidation numbers are equal to their charges. Now, let's have another person take us through number 3. Thank you. Let's have baby layer. Baby layer. Baby layer. Now, baby layer is not unmuting. Now, can we have Slivia? Slivia, Ayeko. Ayeko Slivia. Please, if we are not okay, Slivia,
Good
good.
afternoon, teacher.
Good afternoon. How are you?
I'm Sama.
Okay.
Sir, you talked about the oxidation number of this one. Why you said of aluminium as the oxidation number of what? I've not understood that. Maybe you re-explain.
Oh,
Mm.
okay. You remain on the call and we
Yeah.
look at this. Are you talking about? So we have been on the first point where we say that the oxidation number of any free or uncombined element is 0. So we have been trying to explain what a free element is. And I said that a free element is that one which is not combined with any other. It is just that element alone. And we gave an example of equation 2. Here, aluminium, here it is alone. It is combining with oxygen, which is also alone, which means aluminium and oxygen, they are free elements. But when it forms a product, now it becomes a compound. In this product, which means oxidation number of aluminium will change and the oxidation number of oxygen will change. It will no longer be a 0 because it is in combined state. But when it was free, its oxidation number was 0. Even the aluminium, when it is free, its oxidation number is 0.
Yeah.
Yeah, so I've been explaining what being a free element is, and we're saying that that is when it is not combined with any other element.
Thank you, sir.
Okay, can you take us through number 3 and number 4?
Element number 3 is oxygen.
Okay.
Okay, oxygen generally has an oxidation number of -2, except in peroxides. I don't know how to read that formula.
Okay, thank you. It's all right. Thank you very much. Let me have Shalif take us through. Shalif. 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 Oh, Shalif is not unmuting. Okay. Let me have Isaac Semakula. Isaac. Semakula, Isaac. Good. Isaac, now take us through the remaining 3 points.
Oxygen. Oxygen generally has an oxidation number of -2, except.
And before you continue, can you think why do you think oxygen generally has oxidation number of -2? Where do you think -2 is coming from?
From the charge.
Very good. From the charge. Okay, that is nice. Okay, continue. Except. So it has oxidation number of -2 except. Now, those are just exceptionals. Except, number one, they are giving us in what?
In peroxides, for example,
When it is in
hydrogen peroxide,
good,
sodium peroxide,
very good.
where it is -1.
Where it is -1. Can
Then
you help
in
other continue to number 2, and then you help other members get to the meaning of what they are telling us there? Okay, in compounds,
compounds with fluorine, where it is +2.
where it is +2. Do you think we can help other people understand the meaning of why are they bringing out oxygen?
Now, I have not understood the ozone, why it is negative +2.
Yeah, okay. Okay, generally, we are saying that the oxidation number of oxygen is -2, and you told us that the reason it is coming from the charge, because we say that oxygen has electronic configuration of 2 to what? 2 to 6, yeah?
Yes.
Meaning it needs 2 electrons to become stable. So the ion of oxygen becomes O to power -2. And we say that from number 2, that simple ions, their oxidation numbers are equal to their charges. So the oxidation number of oxygen, here it is -2. But they are giving us exceptions, except if oxygen is combined in a peroxide, then its oxidation number changes to -1. If it is in compounds of fluorine, oxidation number becomes +2. Why? Because we can get it by calculating. If we calculate the oxidation number of oxygen in such a compound, you'll find that it is +2. If you calculate oxidation number of oxygen in this compound, hydrogen peroxide, it will end up becoming -1. But those are exceptions. But normally, in other compounds, apart from these two, it is always -2. I believe that one is clear. We shall be able to see how we can calculate oxidation number of something that we don't know. Now we have other elements. So these are elements that they are bringing out, which are exceptional. While other elements, they move along with the others in those general points that we have given. So they have given us oxygen, that is number 1. Now another element is hydrogen. So who can take us through? Semakula, are you still there?
Yes.
Okay, take us through. So hydrogen and fluorine.
Hydrogen is +1 in most compounds, but -1 in metal hydrides. For example,
Okay.
sodium hydride and calcium hydride.
Sodium hydride and calcium hydride. So generally, for hydrogen, its oxidation state is positive. But if it is combined with a metal, then its oxidation state changes to -1. So those are just exceptions, but generally its oxidation state is +1. Why do we need to know these ones before? Because you'll find out that we are looking at different equations, and therefore you need to be knowing their oxidation states for you to know the ones which we may not be knowing, for those elements that they have not mentioned, as you're going to be seeing later. So we have talked about oxygen and its exceptions. I've talked about hydrogen, and then fluorine, also complete with fluorine.
Fluorine always has an oxidation number of -1 in compounds.
It always. Do you know where -1 is coming from?
No.
You recall what is the
The
electronic
charge.
configuration of, yes?
From the charge.
Yeah, from its charge, because you know that fluorine, it is a 2 to 8 to 2 to 8 to 1. Hey, fluorine. Fluorine is the number 1. That is 2 to 1. 2 to 7. Which means it needs only 1 electron to become stable. Therefore, it becomes F minus. So its charge, and this is one of the monoatomic ion, because it is a simple ion, therefore its charge is equal to its oxidation number, which means it becomes -1. Are we there?
Yes.
Okay. Now, let's have, okay, you can mute, and then we have another person, Belinda. Belinda, unmute.
Yes, teacher.
You're going to take us through the remaining points. The continuation is there. And as I said, we are supposed to be noting down those key points because we're going to use them in our exercise, which we're going to do, practice items. We have like 2 practice items, which you're going to try out. So take us through number 6 up to number 9. And you'll be explaining for us.
Okay, number 6, other halogens like chlorine, bromine, and iodine are usually -1, unless bonded to oxygen or fluorine.
So we are saying that other halogens, you recall even fluorine, which we have already talked about up there, is under halogens. Yeah?
Yes.
So they're saying that other halogens like chlorine, bromine, and iodine usually have also -1. But you're saying unless they are bonded to oxygen and
or
fluorine. So those are 2 areas. Those are 2 areas where it can be different. And when it is with oxygen, we have already seen that oxygen bonded with fluorine, it becomes different. Those are things that we need to just note down. Okay, number 7.
Sum of oxidation numbers. In a neutral molecule, the sum of oxidation numbers must be 0. An example, water.
Have you understood that point? Have you understood it?
Yes, I think.
Okay. So they're saying that in any neutral molecule, which means a molecule is having more than 1 atom, isn't it? So if you look at this, they have given us an example of water. Are we there? We can have another neutral molecule like carbon dioxide. Other neutral molecule, like a molecule without a charge. Any compound without a charge, that one we call it a neutral molecule because it has no charge. Are we there? So they're telling us that if we sum up oxidation states of those elements in that molecule, the total should give us a 0. And that one we're going to apply it very much when you're calculating the oxidation numbers of different elements. Continue.
In a polyatomic ion, the sum of oxidation numbers must equal the ion's charge.
Have you understood that? Have you understood that one?
I'm processing.
Oh, you're under processing. Okay. But as you process, you recall there's somewhere where we talked about simple ions. Yeah?
Yes.
Now here we are talking about polyatomic ion. The other side they talked about monoatomic ion. In monoatomic ion, we say that the charge is equal to the oxidation number. But for this case where we're having a polyatomic, now when you say poly means what?
Many.
So which means there are many atoms, but they are having a what? A charge. So this charge is affecting all these what? Atoms. So they're telling us that if we have such the sum of oxidation numbers must equal to the ion's charge. So, which means if you sum up the oxidation state for sulfur plus the one for oxygen, you should be able to get -2. That is what they are trying to mean. So which means we can use this knowledge to determine the oxidation states of elements which are not known in a given compound. And we shall be able to see that in our exercise where we're going very soon. This one is going to be applied very much, and also this one is going to be applied for a neutral molecule and for a polyatomic ion. Continue.
Number 8, metals in compounds.
Mm-hmm.
Group 1 metals, for example, lithium, sodium, potassium, etc., always have +1 oxidation state.
Do you know where it comes from? Do you know where the +1 comes from for group 1 metals?
It is their charge.
From their charge. Because we know that group 1 metals, they lose their electrons to become stable. If it is lithium, its charge becomes lithium plus. If it is sodium, it is sodium with a plus, meaning it has lost 1 electron. Because in group 1, we know that they have 1 electron in their outermost energy level. Then we have potassium also having a +1. So, and we say that for these simple ions, their charge is equal to their oxidation state. I believe you get to know where it is coming from.
Yes.
Go to group 2 metals.
Group 2 metals, for example, beryllium, magnesium, calcium, etc., always have +2 oxidation state.
Have you known where it is the +2 is also coming from?
Yes, comes from the charge that it gets from its group.
Yeah, so it's still the same case like group 1 metals. Okay.
Yes.
Continue.
Transition metals can have multiple oxidation states, e.g., Fe +2 and Fe +3.
So you have iron 2, iron 3. So the transition elements, for them, they can have a different case. And but if you come to group 3, which we didn't put here, group 3 metals, because group 3 also has metals like aluminium. So even aluminium, it will have which charge? Aluminium has which charge? Group 3 metal.
3.
+3, meaning oxidation state is what?
+3.
So even its oxidation state becomes +3. But when you come to transition metals, those ones which I believe on the modern periodic table you have seen transition metals, yeah?
Yes.
For those ones, we say that they can have even a multiple oxidation states depending on the compound where it is combined to. Yeah. Okay. Lastly, talk about the last one, and then you can start with exercise.
Oxidation number of carbon. Carbon varies depending on the compound, e.g., -4 in CH4 and +4 in carbon dioxide.
Okay, so they're just trying to tell us that for carbon, it varies. It is not standard that it has +4 or -4, but it varies depending on the compound where it is pressed. I believe that one is clear.
Yes.
Okay, thank you for taking us through. So there are only 9 key rules that we follow when we are assigning oxidation states. Let me just start from beginning. So that's where we started from, trying to explain the key rules of assigning oxidation numbers. And now we have come to number 9. Here comes calculations. I have 2 calculations. We are going to do one together, and then the second one, you try it out, and then I'll add also the third one as we move on. Okay, thank you very much for taking us through. Let me have now another person Let me see another person who is ready. Someone who has not told us something yet. Who is that? User one. Can I have user one? User one. User one.
Uh, Good evening, teacher.
Good afternoon. It is still afternoon.
Okay. Well, good afternoon, teacher.
Good afternoon. How are you? What is your name?
My name? Jeremiah.
Okay, Jeremiah. Next time when you are joining, we can always use those names so that we can always identify you with the names. But Jeremiah,
Yes.
Do you have any inquiry before we start with number one?
Okay,
Or
sure.
you can take us
So
through
what?
number one.
I'm struggling with
Yes.
raising up my home place even matching.
Yes?
I'm struggling with raising up my hand. So, but I had many questions from the beginning.
Oh, many questions.
First,
please.
Number one question.
Mm.
Okay, it's about the applications. On the
Yes.
applications.
Mm.
Okay, I didn't understand the point of treating energy pollution, something like that, treatment of sewage, waste management.
Oh, treatment of sewage. So in that one, we say that during the treatment of sewage, there are some cases where you find that the sewage is polluted by maybe some of them are acidic or others are alkaline, and maybe we need to add maybe a metal, or we need to add an acid still to neutralize. So depending on what has polluted that particular surface, or the particular, maybe it is water, depending on the pollutant, it will also give us what we are supposed to add in. So you're saying that when we are treating such areas which are polluted, these redox reactions, you find that they are also taking place in that. Either you have added a metal and therefore it is a reaction of metal and maybe an acid. So you find that at the end of it all, you want to form a salt, which is less, if one produces a substance which is less harmful compared to the one which was there, by reacting by another chemical. But in that process, the reaction taking place is a redox reaction. Are you still there? Hello, are you there? User one, Jeremiah. Jeremiah is gone. Okay. Can I have Jeremiah Masanga? Jeremiah Masanga? Jeremiah Masanga.
Yes, teacher.
Yes, please.
Are we using like a formula to work out the oxidation
Yes.
numbers?
I've not heard.
What is like the formula for working out this? What is like the formula for working out these oxidation numbers?
Oh, that's where we are now. You can see the calculation now. Here we are saying that what is the oxidation number of manganese in the following? Are you saying that?
Yes.
Now we are going to work it out together and we see. Now there is no big formula, but we use those rules that we have been talking about, the rules of assigning to identify oxidation number of a given substance. Are we there?
Yes.
And at the end of it all, we'll be able to know whether a substance has undergone oxidation or whether a substance has undergone reduction. I want us to try out for this now, and then thereafter we'll see how we are going to apply those rules. But let's first look at this. Keep your microphone on. So they're saying that what is oxidation number of manganese in the following? Which name is given to that compound that you're seeing there? This compound. What is the name given to this? The first one.
Potassium permanganate.
Potassium permanganate. I want to add another. Okay, that will be another one. Here we'll be looking at oxidation state of sulfur. This will be for this thiosulfate ion. Now let's look at this one. So they want us to determine the oxidation number of manganese. Make sure your microphone is on. The oxidation number or oxidation state of manganese in this compound. Are we there? Now,
Yes.
there's one thing that we saw in assigning oxidation numbers. Somewhere they told us that the oxidation state of neutral molecule is equal to what?
Yes.
Is equal to?
One.
Is equal to 0. It is here. We said that the sum of oxidation numbers in a neutral molecule, it must be equal to 0. Are you getting that? So because this compound here, it doesn't have any charge, therefore it is categorized under neutral molecule. So when we sum up oxidation state of potassium, oxidation state of manganese, oxidation state of oxygen, it should equal to what? 0. Are we together? Okay.
Yes.
Now, which means since we don't know the one for manganese, we can say let the oxidation number of manganese. What can we call it?
X.
Let oxidation number of manganese be? It becomes what? X. Are we there?
Yeah.
Yes. Do we know the oxidation number of potassium? You recall, we said that it is positive 1 because potassium is group 1 element. Therefore, its oxidation number is positive 1. Do we know oxidation number of oxygen?
Is it -2?
-2, good. -2, and I believe we know where it is coming from. But you recall, though it is -2, we have 4 oxygen atoms. Are you seeing that?
Yes.
And also for potassium, though it is positive 1, but we have 2 potassium atoms. So what are we going to do? So here we come and say, maybe let me bring this. So which means here we're going to come and say, potassium, it is 2 atoms, 2 times positive 1. 2 times positive 1. Are you seeing that? We plus for manganese, we have only 1 atom of manganese, and we say that let oxidation state of manganese be X. So which means we're just going to say plus X. Are you seeing that? Plus oxygen, we said its oxidation state is what? Oxygen. -2, but there are 4 oxygen atoms, so it becomes 4 times -2. So when we sum up all these oxidation numbers, it should equal to what?
0.
0. Good. So this one becomes 2 times 1 becomes, let's be fast.
2.
2 plus X plus 4 times -2. Negative, which is equal to 0. Let's summarize. 2 plus -8, it becomes
-6.
So this becomes X minus 6 equal to 0. Is it clear?
Yeah.
So which means if we want the value of X, X will equal to positive 6.
6.
Have you seen that?
Yeah.
And then you can conclude and say, therefore, the oxidation number of manganese is positive 6. Is it clear now?
Yes.
Now, can you try this one together? Tell me what to do for this one. Manganese oxide. We want the oxidation state of manganese here. What do we do? You be very fast now. Faster, faster.
So let the oxidation number of manganese be like M.
Of manganese.
And
BM.
And I think it's a neutral molecule.
Yes,
So
a neutral molecule
shall we
because
take
there is no charge.
Yeah.
Okay.
So shall say and oxidation number of oxygen is -2. But since there are 3 atoms, we shall multiply it by 3.
Okay.
Then we say plus M
M
is equal to 0.
equal to 0. But don't you think there's a mistake here? It is M, but you call manganese, there are how many atoms of manganese?
2.
2, which means it should be M times 2. Have you seen?
Times 2. Oh, yeah.
Okay, let's move faster. So it becomes -2 times 3 becomes what?
-6.
-6 plus M times 2
2M
equal to 0, which means 2M is equal to +6. So M will be what?
It will be 3. Positive.
Which is +3. So are you seeing that manganese in this compound is having oxidation state of +3, while manganese in this compound, it is having oxidation state of +6. Don't forget that manganese is a transition metal, which can have even more than one oxidation states. Let me hope now it is very clear.
Yes, thank you so much.
Okay, welcome. Now you can mute. Let me have A. You unmute. A.
Yes, please.
Where are you? Do you think you can take us through this number 3?
Yes, teacher.
Okay, good. Take us through. We're going to do it from here.
I think
So
let the oxidation number of sulfur be X.
of sulfur be X. Okay.
So it's X times 2
X times 2
plus -2 times 3
-2 times 3
is equal to -2.
is equal to -2. Why -2 yet we have been equating to 0?
Since it's a polyatomic ion, the sum of the oxidation numbers should be equal to the ion's charge.
Oh, good. Can we clap hands for her and let's clap hands. Let's clap hands for her using those reactions. Let me see those reactions come in. Thank you. That was good. So which means it becomes now
2x minus 6
2x minus 6
is equal to -2. 2x is equal to 4.
+4.
X is equal to 2.
So 4/2, which means x is equal to positive. Now we don't need to leave out this positive sign, because if we leave it out, that will not be oxidation number, because we say that oxidation number should be a positive, a negative, or a 0. So there must be something of a charge somewhere. Okay, thank you very much. I believe anyone with a question on oxidation numbers. Those who don't have questions, we put down the hands, and then I have only people with questions. Please, let's put down the hands. Good. Let's put down the hands. Sylvia, you have put up the hand again. Mirembe Sanyu?
Sir, so I've not understood
Yes.
the way they I've not understood the way they calculated. Like number one,
Which,
where did they get example
where did
number
they
one?
get
Yeah.
the what? Where did they get what?
Where did they get two and they multiply it again over with the one? I don't even know they got that question.
Okay. So maybe a quick one. Where are they getting a 2? A 2, this is the number of potassium atoms. Are you seeing?
Yeah.
So there are 2 potassium atoms in this compound, and a 1 is the oxidation number of potassium, because we say that for group 1 metals, they have oxidation number of +1 because they are charged. They always lose 1 electron to become stable, and therefore they have a charge of +1. Therefore, the oxidation number is always +1. Are we there?
Yeah.
Now, we go to manganese. For manganese, we don't know its oxidation number. That's why we called it X. And because it is 1 atom of manganese, it remains as X.
Yeah.
Then we go to oxygen. There are 4 atoms of oxygen in this compound, and oxidation number of oxygen, we say it is -2, because oxygen, for it to become stable, it gains 2 electrons. So that's where the -2 is coming from. And then we are equating it to 0. Where is 0 coming from? 0 is coming from, we say that for neutral compounds, the sum of the of oxidation numbers is equal to 0.
Yeah.
So that's where it is coming from, and then we simplify, and we got the value of X as +6.
Thank you, sir. What about
Okay, well,
number 3?
now for number 3, the difference between number 3 and 1 and 2, for number 3, it is called a polyatomic ion. It is having charge, but it has very many atoms, so we call it a polyatomic ion. So when we sum up the oxidation numbers of these, it should be equal to its charge. That was in our rule, the rules of assigning. We also talked about that. Do you recall those
Yeah.
rules? Let me bring them back here. Here, where we say that for a polyatomic ion, the sum of oxidation numbers must equal to the ion's charge. So that's what we have been doing there. Is it clear now?
Yeah, thank you.
Okay, welcome. Let me see if we have any other person with a question, then we can go to something else. Melvin? 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 Joshua? Okay, Melvin.
I beg your pardon. So I beg your
Pardon, on
pardon
which
on
one?
the explanation of 3.
Of number what?
Number 3. Number 3.
Okay, number 3. So number 3, we are saying that this is a thiosulfate ion, and we are putting it under. Please make sure your microphone is on so that we can move together. So let me, maybe if I can repeat it a little bit. So we are having it here, thiosulfate ion. Now in this thiosulfate ion, this is a polyatomic ion. A polyatomic ion, meaning it is an ion with very many atoms. You can see you have 2 atoms of sulfur, 3 atoms of oxygen. So we say that in the rules, we say that for such compounds, the sum of oxidation numbers of these elements or atoms present should equal to the charge of the compound. Are we there, Melvin?
Yes.
Now, for sulfur, we don't know it. So we say, let it be maybe Y. So because we are calling it Y, and there are 2 atoms of sulfur, we shall say 2 times oxidation number of sulfur, which we are called Y, plus
Yes.
oxygen. We say that its oxidation state is negative what? Negative 2. But there are 3 atoms of oxygen, so it becomes 3 times negative 2.
2.
Now, the sum of these oxidation numbers should equal to the charge of the compound, which means we should say equal to -2.
2.
So we look for the value of y, mathematics now. So this becomes 2y minus 6 equal to -2.
2.
Are you seeing that?
Yes.
So this becomes 2y equal to +4, and y becomes +2. Is it clear?
Yes.
Yeah, so the oxidation number in this compound becomes +2.
+2. Thank you, sir.
Yeah, welcome. We are going to still apply it in the equations where we are going. Let me hope. Maria, Martha, unmute. Martha?
Thank you, teacher. Good afternoon.
Well,
I
good
want
afternoon.
to ask group 4 and group 8. For them, what is their oxidation number?
Now, like group 8, we have neon, we have argon. These ones, they don't lose any electron or gain any electron, which means the oxidation number remain 0.
Oh, okay, thank you.
Now, for group 4, we already talked about one of the group 4 elements, like carbon, where we say that carbon, it can have oxidation number of 4 or -4. Are you seeing it? Carbon varies depending on the compound, e.g., -4 in methane, +4 in carbon dioxide, which means it is not static. It can change depending on the compound. Are we there? Now, for others, let's see another element in group 4, sulfur. Sulfur. No, sulfur is not in group. That is group 6. Okay, that is group 6. Sorry. Another one is like silicon. So, depending on the compound where silicon is, we can always determine the oxidation number of silicon by calculating, like the way we have been doing. For example, if you have silicon for oxide like this, we can be able to calculate the oxidation number of silicon by using the method we have used here.
Okay, thank you. So
Okay.
if it's maybe like silicon oxide, it's +4.
Yes?
If it's like silicon
which means this
oxide, it's
oxidation number is it is +4.
4. Okay, thank you.
Yeah, welcome. Okay, let's have Ruth unmute. Ruth? Okay, yes, Ruth.
Why is it that in number 2 you equate to 2, but number 3 you equate to 3?
Number 2, we equate to what?
I mean number 1.
Number 1, we equate to 0. Then number 3, we equate to -2. Yeah?
Yeah, why?
This is coming from this. That number 1 and number 2, these are called neutral compounds. They don't have any charge. They are compounds without any charge. And we say that compounds without any charge, then they are called neutral molecules, and the sum of their oxidation numbers, we equate it to 0. While for this one, number 3, it is called a polyatomic ion. For such, we equate the sum of the oxidation numbers to its charge. Maybe, can we try out this? Maybe let me bring this one and we try it out. Let me bring this one, we try it out. If we are to try out for sulfate. Okay. If we are to try out, we are to determine the oxidation number of this, of sulfur in this sulfate ion. Are you seeing this?
Yes.
So then part B, we have for nitrate. Nitrate. Then we can have also for phosphate. So we can determine the oxidation number of phosphorus in this compound, the oxidation number of nitrogen in this compound, oxidation number of sulfur in this compound. And the formulas we use in this case, you'll find out that we are equating to the different values. Why? Because they have different charges. For example, which one can we try out? And then the other ones, we try them out from that side.
Number A.
Number A, but number A is having the same charge as this one. Can you try out for number 3, part 2, now this one?
It's okay.
So, which means our first step will be, we let oxidation number of nitrogen, what can we let it to be?
Y.
Be Y. So, how many atoms of nitrogen do we have?
3.
It is 1 atom of nitrogen. So it becomes Y times 1 plus, what is the oxidation state of oxygen?
3.
Oxidation state of oxygen is what?
3.
Oxidation state. What is the charge of oxygen atom? What happens to oxygen for it to become stable? What happens to oxygen for it to become stable? Yes? We have been talking about this one, that if we are talking about oxygen is in a group 6, meaning that it gains 2 electrons to become stable. And in our rules of assigning, we already saw that oxygen always has a -2 oxidation state. So, which means in this case, oxygen, its oxidation state is -2, but there are 3 atoms of oxygen, so it becomes times 3. Then the sum of the oxidation states of these elements will equal to the charge, which is -1. So this becomes Y times 1, which is Y, minus 2 times 3, which is 6, equals to -1. So Y will become -1 plus 6, and finally Y will be +5. Have you seen where the +5 is coming from? Okay, so that's how we have managed to do this one for part B. So the part A and part C, it is ours for us to try. There's someone who is having help. Help, where are you? Galaxy S5. You're crying. What is the problem, Galaxy S25? You unmute. Galaxy S25. Galaxy X25, you unmute.
Yes.
I saw you cried. What happened?
I had a question.
Yes, please.
Since I didn't attend last week's lesson, so I was asking like the definition of oxidation.
Oh, we said oxidation is the loss. There is a simple formula we had, which we can always use for memory: oil rig, where oil is meaning oxidation is loss, while reduction is gain. So oxidation is loss of electrons, while reduction is gain of electrons. Is it clear?
Yes, thank you.
But that is in terms of electrons. Then we have in terms of oxygen and in terms of hydrogen. But I shared that document for the first lesson. You can also go through it, and even the session is already there on YouTube. I don't know whether you have already seen it. Now,
it's on
I want us
YouTube, right?
to, yes, it is already there. Check in the group. They already shared it there.
All right.
Okay. Now let's look at this one. I see time is running. But I believe we can apply the knowledge we have learned to answer these questions. Are you still there and you read for us the question? Okay. Let me have Babu Elon. Unmute. Babu Elon.
Hello?
Yes, you read for us that question and tell us whether you can answer it using what you have learned.
It's saying which substance is oxidized or reduced. Identify the reducing agent and oxidizing agent. Write the half equation for the reaction.
Okay. So those are three things we are going to learn. So the equation is here. You can tell us magnesium reacting with oxygen to produce magnesium oxide. Now they are saying which substance is oxidized, which one is reduced. Can you answer that?
The one which is oxidized.
Okay, I'm going to allow me take you through and then you'll be able to respond to the next question. Yeah?
Yes.
Okay. Now, when we are answering such a question, I want us to apply the knowledge that we have learned of oxidation numbers. So the first thing we can do is to identify oxidation numbers of these substances on the reactant side and also on the product side of each element, so that we can be able to know which one is oxidized and which one is reduced. Now let's look at magnesium. The oxidation state of magnesium is what? You recall, they say that for free elements, the oxidation number of such elements in a combined state, the oxidation state is 0, which means the magnesium oxidation state of magnesium here is 0. I'm going to be writing the oxidation states on top. Oxygen. What is the oxidation state of oxygen here? Because it is not combined with anything, which means its oxidation state also remains as 0. Let me hope it is becoming clear. Now, in the product side, now because magnesium and oxygen, they have combined to form a compound. Now, in this case, it's no longer a free element. But there's something they told us. Magnesium is in group 2. And they told us that group 2 elements, they always have oxidation state of positive 2. While oxygen, we know it as group 6 element, which gains 2 electrons to become stable, therefore it has oxidation state of negative 2. Now we want to know, among the two, which one is oxidized and which one is reduced. So we are going to look at that. So from magnesium, you see, from magnesium to magnesium ion in the product, it is coming from 0 to positive 2. Then when you go to oxygen, oxygen is coming from, let's look at it, is coming from 0, then it is going to negative 2. Are these numbers increasing or reducing? Then for magnesium, is it increasing or reducing? Here it is coming from 0 to positive 2. So we see some increase. Are you seeing that? Here it is coming from 0 to negative. Of course, now you're going back. So here there is a what? A decrease. So here there is a decrease in oxidation state. Here there is an increase in oxidation state. So which means if it is moving from 0 to positive 2, there's increase in oxidation number from 0 to positive 2, therefore this one is being oxidized. Then this one, because it is reducing from 0 to 2, meaning oxygen is being reduced. I think how we are bringing those ones now is being reduced. And because it is being reduced, meaning it is undergoing, it is undergoing what? Is it undergoing reduction or is undergoing oxidation? And also, which one is a reducing agent and which one is an oxidizing agent? From what we have discussed, can we be able to answer now the remaining question here? We have known which one is oxidized and which one is reduced. So which one is a reducing agent between magnesium and oxygen? And which one is oxidizing agent? Maybe let me have Obela Ethan. Obela Ethan.
Yes, teacher.
Yes. Can you tell us? And if you have a question also, you can ask.
I think oxygen is a reducing agent and magnesium is the oxidizing agent.
With the reason?
I don't have a reason.
Okay, but we need to know the reason why you're calling it a reducing agent and why you're calling the other one an oxidizing agent. Okay, thank you. You have told us something, but now we need also the reason. Okay, thank you. Let's have someone tell us the reason also. Doreen? Doreen. Doreen? Yes,
Okay.
Doreen?
Magnesium is oxidized agent because it loses electrons.
Because
then,
it loses electrons.
Yeah.
Uh-huh.
And then oxygen is reducing agents because it gains electrons.
Okay, before you go away, because we say that oxidation is the loss of electrons, and surely we can see that magnesium is losing electrons, yeah, to attain this. While oxygen is undergoing reduction reaction, therefore there is gain of electron to attain this. Now, we are asking which one is a reducing agent. Can you remind us what is a reducing agent and what is an oxidizing agent? The definition. Doreen, you have gone off. You unmute again. Doreen?
Yes.
What is oxidizing agent and reducing agent?
Oxidized agents is the loss of electrons, while the reducing agents is the gain of electrons.
No, I'm asking oxidizing agent, not what is oxidation. Now, oxidation is the loss of electrons. Reduction is the gain of electrons. But now the question is, what is an oxidizing agent? Okay, Nora? Nora Lozena. Lozena, Nora?
An
Yes.
oxidizing agent is the one that enables another element in the reaction to be reduced, to be
The one
oxidized.
to be oxidized. Good. Actually, last time in our first lesson, we were comparing it with soil erosion. And we are talking about agents of soil erosion. And we say that agents of soil erosion, these are substances or things that cause erosion to take place. So those are the ones we call the agents of erosion. So what causes erosion take place, we call that one an agent of soil erosion. In this case, when we talk about oxidizing agent, this is something that causes oxidation to take place. So when you see oxygen, now oxygen becomes our oxidizing agent. Oxidizing agent. Why? It is causing magnesium to undergo oxidation by gaining electrons from magnesium. While magnesium becomes a reducing what? A reducing agent. It is causing oxygen to be reduced by giving it some electrons. So that is how we can always simply analyze what a reducing agent is and what an oxidizing agent is. Now, number 3, they want us to write half equations. We're going to learn how to write half equations. And by the way, don't forget that if you write half equations and you know how to write oxidation numbers, you're good to go. For example, if you finish assigning these oxidation numbers, then your half equation is almost done. Look at this. Number 1, we start with what? The half equation for oxidation. Which substance is undergoing oxidation? We have seen that it is magnesium. So it is magnesium which is giving us magnesium ion, but magnesium ion with a charge of 2. So it is 2 plus. But what is happening in this? There is loss of electrons. How many electrons are being lost? 2 electrons. So here we can say minus 2 electrons. So the half equations, they even indicate the number of electrons that have been lost or gained. Now, when you look at reduction, now oxygen is the one undergoing reduction. So it is O2, which is giving us O2 minus, like that. But what we have seen is that is gaining electrons. There is gain of electrons. How many electrons? 2 electrons for only one atom. But when you look at this, there are 2 oxygen atoms. So because there are 2 oxygen atoms, we can balance our equation here. When you balance our equation, 2 oxygen atoms, even here we put a 2. So when you put a 2 here, electrons, now they are also going to change. Because if only one gains 2, and now if there are 2, they will gain 4. So this one becomes 4 electrons. So you can see this becomes our half equation for reduction, half equation for oxidation. So when you combine the 2 equations, that's when you get back your original equation here, which is a redox reaction. Okay, I need a question on that and then we can move on. Someone written there, Everest, case Everest. Everest, case Everest. Kathy Serunkuma. Kathy Serunkuma. Serunkuma Kathy. Yes, please. Kathy, what are you saying?
Equations.
Yes?
Pardon, on half equations.
I pardon on half equations, eh?
Yes.
But have you learned how to assign oxidation states?
No, but disturbing.
Okay, let's look at this example and we do it together. Are you seeing example 2?
Yes.
Okay, let's try it together. Now we are going to start with what is the oxidation state of zinc here? Let's be fast. What is it? Yes?
I don't know.
Okay. Maybe let's work with Maria Martha as you also look at this that we can move together. Maria Martha, you unmute. Maria Martha, what's the oxidation state of zinc here? Maria Martha, you're in a noisy place.
Teacher, but it's not noisy. I think
not
someone
you.
is. Yes.
Okay, let me now unmute again, Maria Martha. Okay, I think it's better. Okay, let's move together very fast so that Kathy can understand this concept very well. We are going to answer this question up here using the second. We are going to identify which one is being oxidized, which one is reduced, reducing agent. We write even half equations. Are we there, Maria Martha?
Yes.
Now let's move very, very fast because it's already 4. We are going to borrow like only 10 minutes to complete. 10 minutes to complete. What is the oxidation state of zinc?
The oxidation state of zinc is it is losing electrons.
Here, in this case here, what will be oxidation state of zinc here?
Sorry, in the
equation.
oxidation, yes, it will be.
Do you recall the rules?
Yes.
No, do you recall the rules? The first one, we said that for free elements, their oxidation states is what?
Is positive.
For free elements.
Oh, sorry,
and
it is
combined
0.
elements, we said it is 0. Let's go back.
Yes.
We say that for free elements, the oxidation number of any free or uncombined element is 0. And therefore, since in this equation, zinc is not combined with anything, then its oxidation state becomes 0.
0.
So this one becomes 0. Then which other one is a free element in this equation?
Hydrogen.
So I believe you're meaning this one.
Yes.
So even this one, its oxidation state becomes 0. Are we
0.
there?
Yes.
Now, which means our task is to determine the oxidation state of these ones, hydrogen in this compound and chlorine, and also in this compound of zinc chloride. So let's move step by step. What did we say about oxidation state of hydrogen?
We said the oxidation state for hydrogen is the oxidation state
positive
is positive 1.
Then
yes.
For halogens, we said it is what?
For halogens, yes, since chlorine is a halogen, that is group
7.
7.
So it becomes
-1.
-1. Okay. So I believe now here it is done. Let's go to this product. So for chlorine, we already know it. That is -1. Yeah. Now we need to look for zinc. Now for such compounds which we don't know, because zinc is a transition element, so we can first calculate for it. Are we there?
Yes.
So we say, let oxidation number of zinc equal to, which one can you call it? Equal to maybe Y, yeah? So which means since there's only one atom of zinc, but there's a problem. Zinc chloride is supposed to be zinc chloride with a 2 here.
With a 2, yes.
Yeah? Let's make it clear. there must be 2 here, and then
Yes.
even here there must be a 2 for balancing. I
And
believe it is
zinc.
like that.
Yes.
Yeah. Okay, so let's move on. So oxidation state of it is Y times, it is only 1 atom of zinc, so it's say times 1 plus
Plus
chlorine. Chlorine, it is -1. We multiply by
1
what?
times 2.
Times 2 is
2.
equal to
Yes.
what?
Is equal to 0.
0. So this becomes Y minus 2 equal to 0, and therefore Y will equal to +2.
2.
Have you seen
Yes.
that? So which means
Yes.
oxidation state of zinc is +2.
2. Yes.
Okay. So which
Thank you.
species? Now let's answer. Which species between zinc and hydrochloric acid is undergoing oxidation, and which one is undergoing reduction? Okay, which one is oxidized and which one is reduced?
I think between zinc and hydrochloric acid.
You tell me. I'm trying to just show you what is happening.
Yes, so between zinc and hydrochloric acid.
Which one is oxidized?
Zinc is oxidized.
Are you seeing why?
Yes.
Because its oxidation state is increasing, yeah? From
Yes.
0 to +2. Are you seeing? So, which means this one is being oxidized.
Yes.
Then this hydrochloric acid is being what?
Reduced.
Is being reduced. Now, how do we
Yes.
know? Now, you look at this arrow for red, coming from this chlorine, coming to here.
Yes.
For chlorine, it is having no change. You see, from
Yes.
-1 to -1, no change. But there is
Yes.
hydrogen in this compound. It is moving from +1 to 0, which means there is
0.
reduction. Are you seeing?
Yes.
There is reduction.
Yes.
Therefore, we say it has been reduced. And we say that the one which has been oxidized, it has undergone oxidation. Are we seeing that?
Yes.
And the one which has
Yes.
been reduced has undergone reduction.
Reduction.
Now, which one is a reducing agent and which one is an oxidizing agent among the two?
I think zinc is a reducing agent because
Reducing.
Because the hydrogen ions, it uses the hydrogen ions to become oxidized.
Or to become reduced because it is a
So
reducing agent.
Yes.
So it is causing this one, it is giving an electron to this one for it to become stable.
Yes.
So it causes the other one to gain electron. So which means hydrochloric acid becomes an oxidizing
agent.
Okay.
Yes.
Okay, can we write the half equations?
The half equation.
So we're going to start with the one for oxidation and then the one for reduction.
Yes, okay, for oxidation. We'll have
you just look at these ones. Zinc, and it is giving us what?
zinc.
How many electrons is it losing?
Two,
Losing two
negative
electrons to form
to give
zinc
iron. Two. Okay, yes, zinc
plus.
iron.
Or
Yes.
we can also write it as zinc, giving us zinc ion plus 2
zinc iron.
electron. We can bring these electrons the other side. Yeah?
Yes.
For reduction. Now, for reduction, we need to be careful here as we write it, because you see, for chlorine, it is -1, -1, which means that one is going to die off.
Yes.
Are you seeing? Now, which means in
Yes.
this case we have hydrogen changing,
Hydrogen
ion
to
changing to hydrogen molecule. Have you
molecule.
seen? So
Yes.
you're having hydrogen ion changing to hydrogen molecule. And it is happening by what? By gaining of electrons.
Electrons
By
from
gaining
zinc.
of electrons, yes. But now you recall these are two hydrogen atoms, so even this side you need to balance. We put 2, and because they are 2, they will gain also 2 electrons.
Yes.
So here you get it very right. Even here you get it very right.
Yes.
Okay, thank you very much for taking us through this example 2. I believe even other people have been able to learn from that. So I want to see all hands down apart from those who have questions. We are already out of time. So let me see someone leaving up the hand, the one with only a question, and then we end our lesson. Emmanuel Naduli. Emmanuel? Emmanuel?
Yes, teacher.
You have a question?
Yes, thank you, master. I wanted to ask you that, can I access the group you've been talking about sending the work on a group?
Oh, you're not there?
Yes, I'm not there. Is it the teacher Muto group?
No. It is help senior 4. Help holistic senior 4, senior 4A, senior 4B, and senior 4C.
Master, I'm not there. I'm requesting to add me.
Maybe Abigail, if you're there, you can put the link in the chat so that they can be able to access. Abigail, if you're there, you can do that. Okay, Emmanuel, they're going to share so that you can be able to access. Yeah.
Okay, Master. Thank you.
Thank you. Okay. Lamek, Elima, and Emmanuel, if
Good
you fail to
evening.
get, you can inbox me on that number which I put on the first page so that you can be able, I can be able to add you in that senior 4 holistic group. Yes, Lamek.
Yes, good evening, sir.
Good evening. How are you?
I'm good. For me, I have no question, but mine is just a request. That next time when we come for our lesson for chemistry, at least you could try to give us some chances. Of course, we had some questions to ask, but we never got time to ask those questions. They were before we diving into the examples. So I request next time to give us chances.
Oh, I believe maybe we can always use also the chat, since the hands are always up very many and you fail to get to know who has put very fast the first one. But I believe we shall. But you can still ask that question and respond to it if you have a question.
No, actually, for me, I just wanted to do like some one question from the exam which we have been given.
The questions from the excess, like from the work. Okay.
Yeah, from the work. I just wanted,
No, don't worry. Next week we shall be looking at electrolysis, and after that, that's when I'll be bringing also a scenario question on what we have covered. So what we wanted is to first cover something in this topic, because you can't set an item before learners understand the topic. Yeah. So don't worry, we are going to have those scenario items for us to try out. Yeah, it's okay. I have
Okay.
understood you now. It's all right.
Thank you, sir.
Okay, thank you, Kisache Joel, Kisache.
Good evening, sir.
Good evening.
Teacher, my question is about,
Yes.
we've been hearing
Mm.
you saying oxidizing whatever states. So is it that for any element to have its oxidation state, you must base on the group where it falls?
To know, it is for metals. When you check on metals, for metals
Yes.
group, we say that in the rules, in the rules we say that
Yeah.
group 1 metals and group 2 metals plus group 3 metals, they always take the charge of the element, of the atom of the element. For example, group 1 elements, they normally lose one electron to become stable. Are you seeing that? Meaning
Yeah.
group 1 elements, meaning that group 1 elements, for them, they have oxidation state of +1.
Yes.
Then if you go to group 2, the same case. For them to become stable, they need to gain, to lose 2 electrons. Therefore, its oxidation state is 2. So those are the rules that we have been talking about, and they are the ones that we are trying to follow. Yeah.
Okay. Yeah. So
Yeah.
teacher,
So that is,
will you also be sending us like the notes?
yes, these notes that we are sharing today, as I said, I'll be able to share them in the group for Senior 4 Holistic Learning.
Teacher, I beg you add me there because I'm not there.
Hey, you're also not there?
Yeah.
Okay. So as I said, let's inbox on that number, which is on the cover page of this document. Maybe let me bring it here. Let's inbox on this number. Those who are not in the group, let's inbox here so that we can add you. But as I said, Abigail, you can also put that link in the group, in the chat, so that people can join. So we can use this number. You WhatsApp on that number. Are you able to see it?
Yeah.
So let's WhatsApp on that number, and then we can be able to access the group for holistic learning Senior 4 class.
Yeah. So now my last question is about how you were getting the other negative one that were on hydrogen. I saw you talked about halogens, but I didn't understand it well.
Oh, it is also in the group. When you go their side on the group, group 7, those are halogen elements. And we say that group 7 elements, for them, they gain 1 electron to become stable.
Yeah.
So because they gain 1 electron to become stable, meaning they have oxidation state of -1.
Yes.
So that's where we have been getting that.
Okay. Thank you, sir.
Yes, but all that is in those groups. So I've shared also the link in the group. Let's check on that link so that you can access the work which is there on YouTube. Maybe we can also subscribe on that channel where we normally share other work related to UNEB questions and discussion items. Let's check. I've already put the link in the group.
Okay. Thank you, sir.
Okay. Welcome. As I finish, Eileen.
Teacher.
Yes.
Me, I want to pray.
Yes.
Me, I want to pray.
Okay. So you're going to lead us in the closing prayer, and then we close from here. We shall be having our next lesson on Monday. And as I said, Eileen?
Yes.
So I just want to let us know the next session.
Teacher.
Let's just get to know the next lesson. Those who are copying the number, I believe we are done. I just
Yeah.
wanted to know us to know that our next session is about. Let's look at this. So the next session is this. We shall end up with start with this one, identifying whether the reaction is redox or not using what we have learned today. But this document, I'm going to share it. Let us try out on these examples and the exercise which is in this document, so that we can, when we are coming next time, we can be able to finish it very fast, and then we go to electrolysis. Thereafter, I'll be able to share with us the revision questions in regards to this work. Otherwise, I want to request us to end from here. Thank you for your participation. Let me request Eileen to pray for us and we close. Eileen, lead us in the closing prayer.
Oh Lord, just want to thank you for this moment. Thank you for protecting us. Thank you for being with us through this lesson. I want to thank you for everything and what we have learned. I want to thank you for making us to understand. And for those who don't understand, we pray that next week let us be able to understand. Pray that all Lord guide us, protect us through this day. In Jesus' name we pray. Amen.
Okay, have a nice time. May God bless you.
Amen.
Bye.